Hello, grade 11s. Welcome back to the channel, Science Therapy. In today's lesson, we're going to be looking at exponents and surds. And then, without any further ado, let's look at this question that we have here. So we have question 2. It says simplify fully without using a calculator. So we are given this expression here, and then let's just get right down to it. We have 3 to the exponent of m plus 4 and then minus 6 times 3 to the exponent of m plus 1 over 7 times 3 to the exponent of m plus 2. Now, if we are to apply the law that says if we have a to the exponent of m plus n, this can be expressed as a to the exponent of m and then a to the exponent of n from your laws of exponents, then that means we can write this here as 3 to the exponent of m and then 3 to the exponent of 4. So what we are doing here is expressing this base to each exponent here. Then we have minus 6 to the exponent of times 3 to the exponent of m and then 3 to the exponent of 1. Then over 7 times 3 to the exponent of m and then 3 to the exponent of 2. Right. Now at this point we can see that we now have a common factor of 3 to the exponent of m. Look at this. So this is our common factor here. So that means from the numerator here we can factor out this 3 to the exponent of m, and then if we factor it out from this, then we are left with 3 to the exponent of 4. If we factor it out from this term here, we are left with 6 times 3 to the exponent of 1. Right. Then over here, if we factor it out, we have 3 to the exponent of m, and then we are left with 7 multiplied by 3 to the exponent of 2. Now that we see that these ones are now common, we can just cancel them out, right? So one is in the numerator and one is in the denominator. That means they can cancel out. Now at this point, you can just say 3 to the exponent of 4. That gives us 81. And then what is 6 times 3? That is 18. And then over 7 times 3 to the exponent of 2, we know that's 9. So 7 times 9, that gives us 63. And then this is 81 minus 18 is 63. Then divided by 63, that's equals to 1. Right. So that's how you could have solved that one. Then let's proceed to 2.2. Say solve for x without using a calculator. 2.2.1, we are given x to the exponent of negative 3 over 4 is equals to 8. But since we are dealing with exponents, we know that we have to write the 8 here in terms of exponents. So we can write it as 2 to the exponent of 3, which is a prime factor 2. And then to get rid of this exponent here, we can just say x to the exponent of 3 over 4, and then we multiply by the reciprocal of this exponent. So that's negative 4 over 3, right? But then remember, the rule of math is that what you do on the left-hand side, you also need to do on the right-hand side. Right, so from here, this will just cancel out, then we are left with x. But then here, the 3 will cancel out with the 3, and then we have 2 to the exponent of negative 4. Right, using the law that says if you have a to the exponent of negative m, this would be 1 over a to the exponent of positive m. We can write this one as x is equals to 1 over 2 to the exponent of 4. Right, so this is x is equals to 1 over 16. Now the nice part about solve for x is that you can take the value here that you just calculated, substitute it back into the equation and see if it's gonna give you the answer in the right hand side. So if we say 1 over 16 to the exponent of negative 3 over 4, they should give us 8, right? To confirm that our solution is correct. Then we have 2.2.2. We are given 4 to the exponent of x, and then minus 2 to the exponent of x is equals to 2. Now at this point, we can say that the 4 here is not a prime factor, so we can write it in exponential form to say 2 to the exponent of 2x minus 2 to the exponent of x. Then let's bring over this 2 here, so that's minus 2 is equals to 0. Now at this point, we can use our K method to say we understand that 2 to the exponent of 2x is the same as 2 to the exponent of x multiplied by 2 to the exponent of x. Then let's now say let 2 to the exponent of x be equals to k. Right, so we are avoiding having to work with this. We want to work with something that is much easier to see. So now, because we have 2 to the exponent of 2x, and this is k, and that is k, that means for this part we have k squared. Then minus k, because 2 to the exponent of x is k, then minus 2 is equals to 0. So if we factorize this, that's k minus 2, and then bracket k plus 1 is equals to 0. Then our k is equals to 2, or the other k is equals to negative 1. But remember, we are not solving for k, we are solving for x. So we need to then remind ourselves, but k is equals to 2 to the exponent of x, because we're only using it for the time being, right? Because we didn't want to work with this, it's a bit complicated, so we used k instead. Now that we have found the solutions for k, we can substitute back this original expression. So this is 2 to the exponent of x is equals to 2, which we know 2 is expressed to the exponent of 1. Now the bases are the same in an equation, we can drop the exponents. But what about this side here? This is 2 to the exponent of x is equals to negative 1. Now we know there is no exponent that can give you a negative value here. So we just need to go ahead and say 2 to the exponent of x cannot be equals to negative 1. So this is not applicable, because you can never substitute any value, whether positive or negative, into an exponent and then it gives you a negative value. It never happens. Then let's look at 2.3. It says if x is equals to 3 minus root a over root 2 and y is equals to 4 plus root a over root 2, determine the value of x plus y square. Right, so how are we going to approach this one? We are told that x is equal to this whole expression and y is equal to that whole expression. We must determine the value of x plus y squared. So we have x plus y squared, and then we are told that x is this. So let's substitute. Where there is x, I'm going to substitute that expression, and then over root 2, and then where there is y, I need to substitute this expression here. Then 4 plus root a over root 2. Now we know square, right? Now we know if we have the same denominator, that means we are allowed to do this. We can say 3 minus root a plus 4 plus root a, all expressed to the same denominator here, right? So because the denominators are the same, you can just write all the numerators there and express them to one denominator. Now we have 3 plus 4, that is equals to 7. But negative root a plus root a, that's just 0, so this will cancel out. And then we have over root 2 here. But remember, we still have the square here. Now we know a rule of exponent that says if we have a over b, and then let's say it's expressed to the exponent of m, then each base here needs to be raised to this exponent. So this is a to the exponent of m over b to the exponent of m. This is what we're going to do for this one here. Then this will end up being 7 to the exponent of 2 over root 2 to the exponent of 2. Now 7 to the exponent of 2, that's 49, but then root 2 to the exponent of 2, that's just 2, right? Then our solution is 49 over 2. Right, so that's the value of x plus y squared. Okay, so now we have 2.4. It says, show without using a calculator that root 12, 10, multiplied by root 6, 640, multiplied by root 4, 810, multiplied by square root of 40 is equals to 120. Right, so now this is on changing surds into exponents. So we know a couple of rules on that. If we have, for example, a square root of a, this needs to be written as a to the exponent of 1 over 2 in exponential form. If we have, however, a cube root, so this would be written as a to the exponent of 1 over 3. Also as well, let's say maybe we have a, this is cube root, but then we have a to the exponent of 2. This would come out as a to the exponent of 2 over 3, right? So this is how we would express that. Now let's use that on this question that we have here. So that means writing this in exponential form, it would be 10 to the exponent of 1 over 12, because this is the 12th root. Then followed by 640 to the exponent of 1 over 6. And then here we have 810 to the exponent of 1 over 4. Then followed by 40 to the exponent of 1 over 2. Right. Now at this point we need to write our bases here in terms of prime factors. So we can see that all these numbers here are not prime factors. Now how can we write this in terms of prime factors? We can just use our calculator and say 10 is equals to shift and then fact. Right. So this will come out as 2 times 5 to the exponent of 1 over 12. Now you might argue and say they said without using a calculator. Now this statement doesn't necessarily mean that you do not have to use the calculator in any way, right? It simply means don't punch all this in your calculator and get your answer. So you need to show us the steps, right? So that's why they're saying without the use of a calculator, but it's not saying entirely you must not use the calculator, because if you have to find the factors of such big numbers, you might need to use the calculator for that, right? But then all we are saying here is that don't just come here and say 10 to the exponent of 1 over 2, then it gives you the solution. No, we are trying to make you write this in terms of exponents, right? So hence we are saying without the use of a calculator. Then 640, if we are to use the 640 equals shift fact, this is 2 to the exponent of 7 times 5, and then all expressed to the exponent of 1 over 6. Then 810, this is 810 equals shift fact, that's 2 to the 2 times 3 to the exponent of 4 multiplied by 5, then all to the exponent of 1 over 4. Then the 40, if we say 40 equal then shift fact, that's 2 to the exponent of 3 multiplied by 5, and then all expressed to 1 over 2, right? Then at this point we know of an exponential rule that says if I have a times b all expressed to the exponent of m, then I'm allowed to write this as a to the exponent of m, then b to the exponent of m. So each base here can be expressed to this same exponent. So this is what I'm going to be using now to say, okay, the 2, you can say 2 to the exponent of 1 over 12. Then this is 5 to the exponent of 1 over 12. Multiplied by, we are now on the second bracket, this is 2, because now this, we have an exponent here, and then also an exponent outside. That means we must multiply these two exponents. That's 7 over 6, right? Then we have 5 to the exponent of 1 over 6. Multiply that by this, we are now on this bracket. This is 2 to the exponent of 1 over 4. Then if we say 4 multiplied by 1 over 4, that's 1. And then 5 to the exponent of 1 over 4. Now we are on the last bracket. This is 3 multiplied by 1 over 2. That's 3 over 2. Then we have 5 to the exponent of 1 over 2. Now we know of a law of exponent that says if the bases are the same and we are multiplying, that means we have to add the exponents. So if we say 1 over 12 plus 7 over 6 plus 1 over 4 plus 3 over 2, then you will get 2 to the exponent of 3. So adding the exponents gives you 3, and then you keep the base, right? Then again we are at base 5, so we're going to add all the exponents on base 5. If we say 1 over 12 plus 1 over 6 plus 1 over 4 plus 1 over 2, the solution that we get is 1. So keep the same base and then to the exponent 1. Right, then we are only left with this 3 here, 3 to the exponent of 1. Now what is 2 to the exponent of 3? That's equals to 8. Then multiplied by 5 multiplied by 3. Now 8 multiplied by 5, that's 40. 40 multiplied by 3, that's equals to 120. Now you have proven that this whole expression here is equals to 120. Right. So that's how you could have solved this one, guys. Okay, so let's look at 2.1. It says simplify without using a calculator. We are given this expression here, and the first thing that we need to observe is that the 4 and the 8 are not prime factors. So when we are dealing with exponents, we need to express everything in terms of prime factors. So we have 2 to the exponent of n plus 2, and then the 4 here, we can write it in exponential form in terms of prime factors as 2 to the exponent of 2. Then outside here we have n plus 1. We are writing it like this because we want this 2 here to multiply out with this expression, right? Then the 8 can be written as 2 to the exponent of 3. Then we have n minus 1, right? Again, the 3 must multiply with this whole expression. Then let's do that. We have 2 to the exponent of n plus 2. Then here this would be 2 to the exponent of 2n plus 2. If we do this, multiply that, multiply this, then even here the same thing will happen, over 2 to the exponent of 3n minus 3. Now if the bases are the same and we are multiplying, we know that we have to add the exponents. N plus 2n, that's 3n, and then 2 plus 2, that's equals to 4. So we still keep the same base. Then here we have 3n minus 3, right? Then now we are dividing. If we are dividing and the bases are the same, we subtract the exponents. 3n minus 3n, that's 0, but 4 minus negative 3, that's positive 7. So 4 plus 3, that's 7. So 2 to the exponent of 7, that's 128. And just like that, you would have solved your question. Then let's proceed. We have 2.1.2. We are given all this. Then all we have to do is first multiply out here. So this will just cancel out this bigger square root here. So we'll be left with x plus square root 2x minus 1. And then we can put it inside the bracket. Also, this would be x minus square root 2x minus 1. Right. Now at this point we can see that we have difference of 2 squares. Now if you remember, difference of 2 squares from grade 10 is whereby we had situations like this, whereby if we are given x minus 3 and then x plus 3, this we know that we won't have the middle term because of the negative and the positive here. So we just multiplied this 2 here to give us x squared, and then we multiply the last 2 here to give us minus 9. So no middle term, only the first term and the last term multiplying. Also here we have a similar situation because look at this, we have positive, we have negative, but when we look at the contents of the bracket, it's all the same. We have the x and x, we have 2x minus 1, and then also 2x minus 1 inside the square root. Right, so that means we can just say x times x, this is x squared, and then if we multiply this once, this would be negative, and then the square root will obviously fall off. So we'll have 2x minus 1, right? So this is x squared minus 2x, and then negative and negative plus 1, right? So this is equal to x minus 1, and then also x minus 1. So this can be expressed as just x minus 1 squared, right? Then that's how you do it. Now 2.2 says given p is equals to square root 5 over x plus 2 plus x over 3. For what values of p will for what values of x meant to say will p be a real number? Right. So for what values of x will p be a real number? Now in order to tackle this one, let's just find all the values of x for which p will be non-real, right? So I just want to tackle this in a counteractive way. Then look at this. If we are looking for all the values of x for where p will be non-real, it's much easier to get that one, because we know since we have a square root here, that means the content here must never be equals to negative, right? So we must never find this one as a negative. So the only way we can produce this one as a negative is if this expression here can be less than 0, right? So this is x plus 2 and then less than 0. So this is one condition whereby p will be non-real. But again, this is a fraction. So a fraction is expressed as a over b. If our b can just be equal to 0 here, also this will be non-real, right? So there are now two conditions for which p will be non-real. It's if x plus 2 is less than 0 or x plus 2 is equal to 0. So we have x plus 2 being less than or equal to 0, right? So that means the values of x for which p will be non-real is when x is less than or equal to -2. So we just took this one and transposed, right? So for this condition, p would be non-real. We do understand that. But then remember, the question is not asking where p would be non-real. It's asking where p would be a real number, right? So that means p would be a real number for all the values where x is not equal to -2 or below -2. That means p will be a real number when x is greater than -2. And just like that, you would have solved your question. Then 2.2.2 says, show that p is rational if x is equal to 3. So all you need to do here is just substitute 3 where x is, and then the goal here is just to find an integer value, right? So if we have a definite solid integer value, then that means p is rational when x is equal to 3. So 5 over 3 plus 2, that's 5. 5 over 5, that's 1, and then square root of 1 is 1. 3 over 3, that's 1, so 1 plus 1 is equals to 2. So this means that p is rational if x is equals to 3, because look at the value that we are producing. It's an integer and it's a definite number, right? Then 2.3 says, calculate the sum of digits of 2 to the exponent of 2015 and then multiplied by 5 to the exponent of 2019. So now with this one, you want to express this in this form, right? So if you try to punch it in your calculator, you'd see that that's a deadly mission. It won't even come off. It will just tell you maths error, because this is a very, very big number here. Now what you're gonna do is look for the smallest exponent and then try to express the other one in this same exponent. So we have 5 to the exponent of 2015 multiplied by 5 to the exponent of 4. So we just found a way to write 2019, but then in terms of the exponent of 2015. So we know 2019 can be written as 2015 plus 4, right? Then this is just manipulation because there is 2015 here, right? I could have expressed it in any number, could have just said 2010 plus 9, but then I'm trying to manipulate so that I have the same exponent, right? Now, if I have the same exponent, that means I can now use the law that says if I have a to the exponent of m multiplied by b to the exponent of m, I can just say this is a times b all to the exponent of m, right? So that means I have 2 times 5 all to the exponent of 2015. Then this is multiplied by 5 to the exponent of 4. 2 times 5, that's 10. And then to the exponent of 2015. Then 5 to the exponent of 4, that's 625. Now we know one thing about exponents, especially if we have base 10. If we have base 10, the exponent here just simply indicate the number of zeros that you have. For example, if I have 10 to the exponent of 3, that means I will have a 1 and 3 zeros. If I have 10 to the exponent of 6, that means I have 1 and 6 zeros. So that means here I have 1 and how many zeros? 2015 zeros. But then what am I looking for? The sum of the digits. I'm not looking for the value here. I'm looking for the sum of digits. So the digits that I have here is 1 and 0. Now if I add all the zeros here, 2015 zeros, it would still give me 0, right? So 0 times 0 or 0 times 2015, that's just 0. Then plus 6, this is a digit, plus 2 plus 5. Now the sum of digits, it's 1 plus 0 plus 6 plus 2 plus 5, which will give me 40. Okay, so we have yet another question 2. It says simplify the following fully. Then we are given this expression here. So we know that using the law of exponent that says if I have a to the exponent of m plus n, this can be expressed as a to the exponent of m and then also a to the exponent of n. Then we can use that to write this one out. This would be 3 to the exponent of x, 3 to the exponent of 1, minus 3 to the exponent of x, and then 3 to the exponent of negative 1, right? Over, let me just rearrange this one. This would be 3 to the exponent of x, and then multiplied by 2. Now looking at this, check. I've now found a common factor in between these terms, right? So this is a common factor. So that means I can factor it out. 3 to the exponent of x. If I factor it out from here, I'm left with this 3 to the exponent of 1, which is just 3. Then if I factor it out here, I'm left with 3 to the exponent of negative 1, which is 1 over 3, right? Then over 3 to the exponent of x, and then multiplied by 2. Now look at this. This 2 can now cancel out. So you can only cancel them out after you have factorized. You cannot just come here and cancel, right? You need to factorize first, and then when it's like this, you can now cancel out. Then this is 3 minus 1 over 3. That gives us 8 over 3. Then we have this 2 here, so we can say divided by 2. Now at this point, you can just go ahead and punch in your calculator. That's 4 over 3, right? Then you are done. It's only 3 marks. 2.2 says solve for x if we are given that equation there. So we have a square root x minus 2 and then to the exponent of negative 3 is equals to 64. Now knowing our Surds rules, we know that this must come out as x minus 2 to the exponent of negative 3 over 2 because it's coming out from a square root. So we have this over 2 here. Then it's equals to, let's write 64 in exponential form. Remember, we are dealing with exponents. So 64 equals shift fact. That's 2 to the exponent of 6. Note that I'm also writing it in terms of prime factors, 2. Right. Then to solve this, we can just get rid of this exponent here by doing what? Multiplying by its reciprocal. So we have negative 2 over 3. But what we do on the left-hand side, we also need to do on the right-hand side. So that's negative 2 over 3. Now this will cancel out. So we are left with x minus 2. But here, 6 multiplied by negative 2 over 3. Let's punch that. So we have negative 4. So this is 2 to the exponent of negative 4. Now we know this can be written as, so drop down the x minus 2. This can be written as 1 over 2 to the exponent of 4. From the law that says if I have a to the exponent of negative m, this can be written as 1 over a to the exponent of positive m. Right, so this is the law that we used. So we have x minus 2 is equals to 1 over 2 to the exponent of 4. That's equals to 16, so 1 over 16. And then this will be equals to 1 over 16 plus 2, right? Then what would be the solution here? That's 83 over 16, right? Now, nice part about solve for x, you can just substitute the value in here to see if it's gonna give you 64. So if you say 33 over 16 minus 2 to the exponent of negative 3 and then put it inside the square root, then you have to find that 64. So let's check. Let me just double check with my calculator. Then minus 2 to the exponent of negative 3. So yeah, I'm definitely getting 64. So that means our solution here is correct, right? Then 2.3 says rewrite the following expression as a power of x, right? So do not be intimidated by this, guys. So you have your x here. Your x is expressed to the exponent of 1. So this is a square root here. That means we'll have x to the exponent of 1 over 2. But once we have a square root inside of another square root, then it becomes the fourth root. So we have x 1 over 4. And then if we have if we have this square root inside of the fourth root, then that becomes the 8th root, right? So that's 1 over 8, right? Then down here we have x to the exponent of 7 over 8. Remember, it's coming from the 8th root, so it needs to say over 8. Right, then at this point we are multiplying and the bases we can see are the same. That means we can add the exponents. So we'll say 1 plus 1 over 2, and then plus 1 over 4, then plus 1 over 8. Right, so this will give us x to the exponent of 15 over 8, then divided by x to the exponent of 7 over 8. Now at this point we can see we are dividing and the bases are the same, so we need to subtract the exponents. That's x to the exponent of 15 over 8 minus 7 over 8. Now if you say 15 minus 7, that's 8, so we're going to end up with 8 divided by 8, which is 1. So that's x to the exponent of 1. Right, so they said rewrite as a power of x, so that's x is to the exponent of 1, or you can just say it's x, right? Because remember, x to the exponent of 1 is just x. Then that's how you could have solved the question, guys. So make sure you keep on practicing these questions, and then if you found the lesson helpful, please hit the thumbs up button. Then if you are watching and you haven't subscribed yet, what are you waiting for, man? Please subscribe, and then don't forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.